Thank you.
Okay, so the next speaker will be Dr. Yamashita from JAIF. Okay. I think I know him when he's engaged with mission to the VTM. Okay, so so now I let Dr. Yamashita to deliver his presentation. Okay, so the word is yours, Dr. Yamashita, please.
Yeah. Can you hear me? And also, can you see my
Yes.
my presentation material?
Yes.
Yeah. Is it clear?
Yes.
Okay. So nice to meet you, Aziz-san. Yeah. After a long time, I'm very happy to see you. Yeah. You are still active. Okay. I have studied in Malaysia. Tuan dan puan-puan. Selamat pagi. Assalamualaikum. Okay. Okay. I'm really so truly glad to be invited to the International National Conference of Malaysia Nuclear Society. Thank you very much for the invitation. Okay. And so I have many friends in your countries, but I'd like to introduce myself. I'm the KIYONOBU Yamashita. Okay, here. Of the JAIF International Cooperation Center. I was actually the director for HRD Center of the JAEA. Yeah, I have enjoyed very much with the many friends from Malaysia. Now I'm working the more, so focusing the, how can I say, distributing the Japanese safety technology of the NPP to NPP embarking countries. Yeah. Today, I'd like to present about the nuclear science and the technology for socio-economic development. Aziz-san, can you hear me well? Okay?
Yes.
Yeah?
Yeah, I can hear you very well. Yes, good. Thank you.
Oh, very nice. Thank you very much. Yeah. Okay, then next page. Yeah. Before to start going to my main theme, I'd like to report the present status of Fukushima. I assume you're interested what Japan now is.
Yes.
Yes, yeah. I'm very sorry that the Japan occurred the accident of the Fukushima Daiichi. Yeah, I'm very sorry for that. Yeah. But the Fukushima Daiichi, the commissioning is in progress. You can see visitor can stand the about 100 meter close to the Fukushima Daiichi NPP plant. It was done the accident. Yeah. You can see the visitor have no mask. Yeah, no problem. Yeah, now due to the COVID, visitor have the mask, but not due to the dust, radioactive dust from NPP or something. It is very well, how can I say, progressed. Also, you can see a big crane. They are operated remotely from other side, other position. Yeah. And okay, later you can please visit the following URL. Yeah. You can see inside of Fukushima Daiichi very clearly how now is it. Yeah. Okay, this view graph shows the Fukushima revitalization. The upper part, it shows the unit 4. After a hydrogen explosion, it was broken as shown in picture. Now it is, how can I say, repaired. It was necessary to repair this facility to remove the spent fuel from this facility. The old fuel was removed from spent fuel pool. It is completed. Also, the infrastructure restoration near Fukushima Daiichi accident, Daiichi, is like that. This highway is about 4 kilometers from Fukushima Daiichi unit, NPS. And they are already restored 2015, and it is already used. Also, the railroad was restored, what can I say, March 2020. Therefore, you can take the train, Joban line, from Tokyo to Sendai, the school here. Yeah, please visit here with your radiation detectors. You see how reduce that. Okay, but also you have a strong concern about the tritium boy alive your countries. Many boy visit your countries. This view graph shows the I read the nuclear facility both at home and abroad in tritium is discharged as liquid waste into the river. For example, in France or something, the NPP are constructed near river and the sea, and also into the atmosphere through the ventilation process in compliance with the domestic law and regulation. Okay? And the Fukushima plant to release the tritium waters less than 22 T is, how can I say, pronounce, trillion becquerel. But please see that the CORI in NPP in normal operation release the tritium annually already 91 trillion becquerel. It is about 4 times more. Also, you can see the PWR in China, close to Malaysia, released the already 98 trillion becquerel in normal operation. Yeah, please keep this real situation. Many nuclear facility release tritium to see. Yeah, because the PWR, they use the boron acid to control the reactivity, and they make the nuclear reaction, and it became tritium. Therefore, the PWR release more tritium than BWR, and the release of tritium from Fukushima is much less than of them. Please keep remember that. And the next page, and this tank, it contains the tritium contaminated waters here. And after the release, the environment radiation dose very slightly increased. Its natural radiation in Japan, in average, is 2.1 millisievert. But by ocean release, the 0.00007 millisievert per year may be increased. I think the influence to Malaysia is negligible, and I can say there are no effect to your countries, I think. Okay, now a little happy side of Japan. This view graph shows the NPPs restarted and in operation. We are planning the 39 reactor to restart again. And here 10 reactor was restarted already. Yeah. Also These reactors are standing in very nice landscape. Also here you can see Mihama number unit 3. It is behind the you see the unit. Yeah, there are many people are enjoying the swimming in summer. Okay, now I would like to start with the main assignment. I would like to present about nuclear science and technology for socio-economic development. Yeah, nuclear socio-economy consists of the nuclear. Okay, I am too fast. Yeah, I can go slowly. Anyone, if you have a question, you can stop me anytime. Okay. The nuclear society economy consists of nuclear energy and radiation application. I would like to start with radiation application. Yeah? Radiation is used in various fields as very useful tools. Yeah, for example, tomography, computed tomography, X-ray photograph, food preservation, material modification, water flow survey, thickness meters. Yeah, for example, the steel industry, they use the very hot steel. This steel will be the thickness will be measured with radiation, gauging, chemical analysis, and chemical composition. But surely we have to always consider the negative effect, negative health effect, such as cancer. Yeah, but we have so many opportunity to do with radiation application. Okay, yeah, I'm very interested in this physics of the positron emission tomographies. Yeah, the fluoride 18 compound, it is a positron emitter, is injected in human body, and it will be accumulated. This composition is accumulated extra in cancer area. Because cancer accumulated, they try to accumulate many things in their cell. And the fluoride compound emits the beta ray. The beta ray takes the electron around there, and they produce 2 photons. They fly in anti-direction. Yeah? From detector, with detector, they determine the position of the where this photon come. Photon come from the cancer area. The position of cancer will be determined from 2 gamma ray that fly in opposition direction. It is wonderful physics, wonderful application of the radiation. Yeah, if you have idea with radiation, many idea, you can develop many interesting tools. So it means that you can make a business. Also, this view graph shows the boron neutron capture therapy. It was carried out in the JRR4. It is I think the ideal cancer therapy. For example, boron compound is injected to body, as they are selectively collected in cancer cell. As I said, cancer cell accumulate or eat every material. They cannot decide it's good. This food is good or not. The normal cell selects that, but the cancer cell does not select good compound or bad compound. Then cancer cell accumulate the boron compound in cancer cell. After then, neutron beam from reactor irradiated to the area of cancer cell part. And then in cancer cell part, boron make a reaction with the neutron and become alpha particle and lithium. The flight length is about 10 micrometers. It means this high energy alpha kill selectively the new cancer cell. It is ideal. Any good medical doctor cannot take out selectively only cancer cell. But this, the boron neutron capture therapy, it make possible to kill only the cancer cell, and the normal cell are still be alive. It is ideal cancer. This is also nice application of radiation. Also, this is a treatment of the result after boron neutron capture therapy. It's before that. This is medical irradiation for malignant melanoma on the soil of the food. After 3 months later, a little injured, but after 6 months later, cancer was removed. A normal, how can I say, surgeon, the patient food should be killed. So how can I say, take out, cut, about close to the full food, feed. But with boron neutron cancer therapy, it is well healed by this therapy. Okay, and also the radiation application gives the so different many interesting opportunity. The life cycle of the melon fly. Yeah, please start. Yeah, melon fly are very happy and mating together, and after then they give the egg. Egg becomes the larvae, and these larvae feed the fruits and vegetables, and the fruit cannot be sold, cannot bring to the market. Yeah? For example, if you have nice fruit, and you cannot export this fruit to other countries. And then, okay, this larvae become a pupa in soil and marsh, and born again female male, and they produce again they make mating and egg. But if you put the sterilized male by irradiation, and this sterilized male disturb this mating, and after then, by sterilizing male melon fly cannot produce its offsprings. They cannot, no children or offspring are produced. Then this view graph shows the eradication of melon fly by radiation in Okinawa Island. It's a south island in south of Japan. Yeah, the sterilized fly are put in the environment. At the number of the sterilized fly increase, but the normal fly decrease after several years. Yeah. 3 years, and then there are no more melon fly in Okinawa. Then the vegetable from and fruits made in Okinawa can be bring to the Japan, the main island, and also export to the other countries. And the farmer get more money from this nice mango. How is it in Malaysia? Do you have also mango? Can you export your mango to every countries? Okay, it is my favorable application, radiation application. My favorable application, radiation application, is a neutron activation analysis. Yeah. Then when material absorb neutron, they become radioactive. Yeah? And the radioactive ray precursor to the material are then emitted in the activation analysis. The element composing the material, including the extremely small amount of the impurity in material, can be determined by measuring such emitted radiation. Yeah, if I visit the abroad, and I try to get the soil a little, and I bring it to home and to make the neutron activation analysis, then I find the easily if there is gold. Yeah, it is a very nice method. You can very small amount of gold you can detect also. Yeah, yeah, this is a very nice method. Yeah. Okay. This view graph shows the conclusion about the radiation application and economics stayed in Japan. The industrial use of the radiation application gives the 2.22 trillion yen. Trillion yen. It's a big amount. Also, the medical use brings the 1.91 trillion yen money. And agriculture, the use the 0.2 trillion yen. Yeah. Total, the radiation application bring 4.37. Yeah, about 4 trillion yen. It's a big amount of money. The main for industrial use, this for radiation is very well used semiconductor processing, and it is very famous. Also, you drive a car, and every time you use the radial tire, the manufacturing of the radial tire is this radiation is inevitable. Also, medical use, CT, cancer screening, and the potato or agriculture potato sprout stop. If you find if you have idea, you can find many nice business or find interesting tool. If you understand the radiation application, radiation very well, you can find your idea and find the contribute to the socioeconomy. Yeah. Okay. I back as I said, socioeconomy, nuclear socioeconomy consists of nuclear energy and radiation application. In Japan, the business with the nuclear power plant is about 5 trillion yen. And radiation application already, as I said the last view graph showed this about 4.37. Yeah. So Raf said the trillion yen. Actually, the business with radiation application is comparable with the business with the nuclear power plant, nuclear energy. Therefore, yeah, I remember very often about several years ago, I am invited by the Professor Kaiser to UTM, and I have given the lectures. Besides the NPP, I have given the application of the radiation application. Yeah, and I explained there is also many possibility to do the radiation application. I often remember that. Okay, now I'd like to start a little mention the nuclear energy business. Yeah, oh, how many NPP are necessary to supply the whole electricity power for all population of Malaysia? The population of Malaysia is 33 million, and I estimate for 1 million you need 1 gigawatt electricity. It means about 1 person 1 kilowatt. Yeah, 1 person 1 kilowatt, 1 million per population 1 gigawatt. It means 33 gigawatt. Maybe it is not so good to cover the energy demand only with NPP. Maybe 1/3, maybe 10 NPP is very well to have NPP. I think in Malaysia, yeah, and NPP are very useful to stabilize power supply. But your country have many concern about the radioactive waste management. In Japan, yeah, there's a different method to contain or keep the radioactive waste management. The space disposal, it is a very not so high reliability. And also ocean dumping, this is banned by London Convention. It is a nice idea, but it is also the ice sheet disposal. It means you bring the radioactive material to the Atlantic, Antarctic area, and the radioactive waste is a little hot, and ice will be melt, and the can with the high level radio waste fall down during the melting the ice and fall down. After then, this water will be frozen again. I think this is a very nice method, but this is also banned by treaty. Therefore, we have only the geological disposal, and with Japan, we decided to do the geological disposal. The high level radioactive material will be disposed 300 meters deep in earth. And surely you have concern, maybe it makes the, how can I say, the barrier will be intact, and the radioactive material can decay. After rough calculation, it shows maybe after 6,000 years, can arrive a small amount of radioactivity, and after 6,000 years about, and very slightly the natural radiation may increase. This is the effect. It was calculated. Okay, it is a decision. Technology is already given, and I think the Malaysia is more stable than Japanese ground, I think. Okay. Okay, next one, Japan, the JAEA promote to develop the high temperature gas-cooled reactors. Surely with this reactor, we can produce the electricity also we can use for the gas turbine electricity production with gas turbine. But this reactor is now developed to produce hydrogen. This reactor we are able to have the heat of 950 centigrades, and this makes we can make the hydrogen from this waters directly, and it does not produce any carbon dioxide. Yeah, and this is the fuel. Okay, and also fast breeder reactor is very useful to use the uranium. For example, now we can use only the uranium 35, only 0.7%. If we have the fast breeder reactors, we can use also 99.3%. We can use as fuel for NPP. Then we can have about 16,000 years energy, but actually about 5,000. Okay, I think anyway most important is the education to obtain benefit of socioeconomy from nuclear science and technologies. Okay, I skip that. Yeah, we support Japan Nuclear HRD Network supports the education in elementary school, also high school, university, and also young researcher and also foreigners. Japan Nuclear HRD Network support the education. And also we check very much the description and textbook in the middle school, secondary school, high school, and so on, and improve the textbook. And also, yeah, I have been in Malaysia. I have seen visit the secondary school in Kajan. This school give very nice lecture. What is the nuclear radiation? I impressed that the Malaysia do very well. Lecture about radiation and the nuclear in science, technology, engineering, math in the secondary school. It is very nice. Yeah, I hope Malaysia keep this this education. And I personally hope that HRKD network will be continued by the support of the Nuclear Malaysia to promote the nuclear science and technology for the socio-economic development in Malaysia. Actually, this network is, how can I say, established by the effort of the MNPC, but this is no more there. And I hope that the Nuclear Malaysia take this position and keep this network, promote the education, nuclear science technology for socio-economic development. Okay, thank you very much. I say the summary, Fukushima is in vitalization, and there's many interesting radiation applications that contribute for socio-economy. The socio-economy of radiation application is comparable large to that of the nuclear energy in Japan. And LWR, FBR, HTGR contribute for the socio-economy that for the reduction of carbon dioxide. Education about nuclear and radiation is necessary to develop the nuclear science and technology for socio-economic development. I think it is wonderful that Malaysia promotes the science, technology, nuclear, engineering, and mathematics STEM, and include this radiation and nuclear in this STEM. Thank you very much for your kind attention. Thank you very much. I'm finished. Okay. How can I say video stop? No, I can show you.
Okay. Do you have any?
Okay, any question?
Yeah, I open to the audience. Any question to one question or two questions?
Yeah, Prof. Yamashita, Wateshwa Nahru Sandes, UTM Karang.
Nahuru-san, yeah.
Nahru, yeah. Yeah, I have actually three questions from your presentation. Very interesting presentation, by the way. One is on the Fukushima. So, what is the
Yeah.
plan, the future plan for the site? Yeah? Is that a new reactor will be there, or what? And secondly, is that on the
Okay, one question. One. My
of them.
brain is not so good.
Okay,
So
okay, all right. Sure, yeah.
you asked about the
One by
Fukushima.
one.
Yeah, Fukushima. What is the future plan after everything is rehabilitated at the current site of the reactor? Is anyone going to be put
Your
there?
question is what will do with the Fukushima Daiichi after
Yes,
the
yes,
something?
right.
Oh, it is no more possible to rehabilitate the Fukushima Daiichi. We will do only decommissioning. Okay?
Okay, all right. The second one is that on the socio-economic contribution of nuclear science technology that you mentioned about 4.27 billion yen in 2015. What is that in terms of percentage GDP?
GDP.
Yeah.
Yeah, I don't know exactly GDP, but I know only the Japan's budget. Total budget is about the 100 trillion yen.
Oh, okay.
Yeah,
Yeah.
total budget, the governmental budget.
So that'll be around
About
4%, something
120.
like that.
Yeah, okay.
Yeah. All right. Okay, that's good. So probably we need to check also how much is the impact of the use of nuclear technology here in Malaysia. Yeah. Maybe
Third question?
the last one that I would like to ask from you is that you mentioned that you estimated that 1 million population will require around 1 million 1 gigawatt, right?
Yeah.
Yeah. So I'm looking at Japan, for example, have about 126 million population, and you have around about 40, 50 nuclear power plants. So how do you come up with the remaining power from what sources?
Thank you very much. Then, okay, then we use not only the nuclear, we use also import the natural gas from Malaysia, and we call
Okay, all right.
coal. Therefore, the very roughly said, maybe the 1/3 of the total demand of the new electricity supply should be the nuclear. Then you can stabilize very well. It means they're about 10. Yeah.
I see. Okay.
And also the 1 gigawatt per 1 million. Yeah. If you see you have the 200 volt. Yeah. And every house you have the breaker. Breaker.
Yeah,
Electricity breaker.
Yeah.
And you multiply with the volt and divided by your member of the house. Every house, every person is very roughly 1 kilowatt are necessary.
Yeah, right.
Yeah, okay. Okay?
Okay, arigato. Yes.
はい、どうも、テレマカシ、yeah. Yeah.
So, last question from the audience. From the student, your ex-student.
Yeah, the Mr. here, the laughing, Alif was my student about 7 years ago. Yeah, I remember very well.
Yeah, we met in Tokyo.
Tokyo also, and also the in UTM.
Yeah. So
Okay,
I don't have any question, but thank you for attending our conference.
Yeah, thank you much. I was very glad to meet all of you in Malaysia. Yeah, Adil-san also, you also, many, Kaizuru-san. And
Okay,
thank you very much.
Dr. Yamashita, this is my opinion. So I've seen your slide in the networking, but I don't see how NGO, okay, like our Malaysian Nuclear Society or other nuclear society to play a role in your networking.
Yeah. Your question is why the nuclear society should not work. Yeah. Surely you can work. Yeah, network is not only one. You can cooperate very well with the nuclear Malaysia, maybe. Already you cooperate very well to how can I say, to hold this very nice conference like that. But sometimes for the network, some money are necessary. Yeah?
Yes.
Usually the nuclear society is not so rich.
You can make
invite something or something to do that. Yeah, nuclear Malaysia get more the how can I say maybe the more contact with the government.
You know, because I'm why I raise this, because in many technical societies, we don't have industry people to join because to them they don't see this important. But I believe that we need the industry to join this society, so they can see what is the socioeconomy that can benefit to them. So that's why if we can NGO can come into the networking, and then these industry people can see the importance of these the technologies to them, because like you said, then by then they can see how much money they can make in 10 or 20 years time on the nuclear application. Okay? So that's my opinion.
Yeah, thank you very much. Yeah, anyway, yeah. I hope this network, which is established by the MNPC, it will be kept for the nuclear science technology for socio-economy. Yeah. Now it's difficult to keep for nuclear power, but the nuclear society socio-economy is very good. It can be kept. Thank you very much.
Okay, thank you again,
All of you.
Dr. Yamashita, for sharing.
Jumpa lagi.
Yeah.
Bye-bye.
Yeah, chaos ticketed,
Hai hai, domo.
Domo.
Okay.
Domo. Okay.
Dr. Aziz, your mic is mute.
Okay. So thank you to our two keynotes, the Professor Dr. Rob Robinson and then Dr. Yamashita. Okay. So I hope we can meet you again, and I hope if we can travel to Japan, I'd like to meet you in Tokyo. So we have more discussion on how to make MNS rich.
Yeah. Yeah. Let's do that.
Yeah.
After COVID, surely we meet it again. Yeah.
Yes. Okay, so I give back to the Master Romani to continue this conference. Thank you very much.
Thank you.
Bye-bye.
Bye-bye.
Yeah.